Hello everyone, I am Dr. Tanmoy Biswas. Welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. Which one is the most acidic and which one is the least acidic among this molecule? I request everyone, please pause this video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, whenever the question about acidity given, remember one thing, conjugate base. More specifically, if I say stability of conjugate base. If the conjugate base is more stable, then you can expect its acidity will be higher. Okay. So if you look at all this molecule, option 1, 2, 3, 4, if you remove the proton I mean this proton, it will be this negative charge, all the thing. Now, if you want to know their acidity, first let's know their stability of the conjugate base, how the conjugate base is stabilized. In case of 1, this carbon is actually sp hybridized, and along with that the -I effect of this carboxyl group helps to stabilize the conjugate base. Now you may think, sir, alpha beta unsaturated carbonyl type, because this is my functional group, this is alpha, this is beta, isn't it there any conjugation? Now if you look at such kind of case, no, not possible. Why? These cannot come. Okay, these cannot come in resonance, not possible. Another, in this way the carbon's valency will exceed 4, which is also not possible. So here the stabilizing factor is sp hybridization, because we know the electronegativity of sp carbon is higher compared to sp2, which is higher compared to sp3. So this is one point, and second point, -I effect of COAT group. Now the next option, this is carboxylic acid. If you remove this carboxyl proton, what's remaining? This O-, this is the conjugate base. It is resonance stabilized. So you can draw one canonical form in this way. So it's like that, it is O-, it is double bond O. So this is the carboxylate anion, and there are two canonical form, or more accurately if I say, it is equivalent canonical form, means this canonical form and this canonical form same. So that's why it is called equivalent canonical forms. And remember, in case of equivalent canonical forms, the delocalizations are very high, because same, both are same. So delocalization is very high, means conjugate base is more stable, means negative charge is delocalized, it is stabilized. Third point here, if you look at, it is actually a phenol derivative, this methoxyphenol derivative. So if you remove this proton, it is more acidic compared to this CH bond, obviously, since it is attached to more electronegative atom oxygen. So O-, and it has another kind of resonance stabilization, means with this benzene ring. So I am drawing one canonical form, student. There are many other canonical forms also possible. I will not draw. I suggest you in home, please try by yourself. So this is oxygen, this is methyl. Now rest of the bonds are as it is. Now there are other canonical forms also possible. For example, it can come here, this can open like that. Now next one is option 4. It's a sulfonic acid, benzene sulfonic acid, and this proton is the most acidic, obviously. So if you remove, this is O-, and in this case, student, I'm drawing one canonical form. So this is PH SO-, this is double bond O, another is double bond O. Now if you look at it little closely, okay, another canonical form also possible. So you may consider it will come here, it will open up. And in this case, canonical form, this one, for example, A, B and C, all are same. So you can say 3 equivalent canonical forms, means very high delocalization of this oxygen. Not only that, here the atom is sulfur, previously here the atom was carbon. So sulfur is more electronegative compared to carbon. So consequently, this O- is a very high stabilized. How? By the -I effect of sulfur, because it's a significantly higher electronegative atom, and in this case 3 equivalent canonical forms, such that this O- is delocalized, this negative charge is delocalized equally all over these 3 oxygen atom. Means higher the delocalization, higher the stabilization, and among all these you can expect that these O minus in option 4, it is maximum delocalized, so it is maximum stabilized. Now here there is one term called pKa. What is the relationship with pKa and acidity? If acidity is higher, pKa is lower. pKa definition is minus log Ka. Okay, so remember the equilibrium constant or dissociation constant, or this Ka more, pKa less. So lesser the pKa, stronger the acid. Now look at here pKa of these different acids. This acetylene case means terminal alkyne, pKa 19. Now look at phenol, the next one is 9.65. okay, fine, phenol's acidity is actually close to 10, like that. Carboxylic acid, acidity 4.84. okay, fine. And look at the acidity of here, minus 2.8. yes, minus. For stronger acid, pKa value can go beyond 0. So this is benzene sulfonic acid, and remember its acidity is comparable to inorganic acids. So that's why this is the maximum acidic, and ethyl ester of acetylene carboxylic acid is the minimum acidic. Okay, so this is the answer. So anything could be asked in your question. So I have already explained the logic behind their acidity and how the conjugate base is stabilized. So this is the overall discussion. I believe this video may be useful. By the way, if you get this question in your exam hall, remember one statement, very important. Sulfonic acids are very strong acid. Their acidity is equivalent to inorganic acid, means very strong acid compared to normal. By the way, carboxylic acids are weak acid. Phenols are lesser acidic compared to carboxylic acid, and obviously alkynes, they are not that much stronger acid at all. But if you say sp3, sp2, sp, in that case this terminal alkyne proton or sp proton is the acidic, most acidic one. That's another issue. So this is the overall discussion. Now if you really consider the content of my channel is worthy, please help this channel to grow. And for any doubt regarding the logo of my channel, I request everyone to read this part, then your doubt will be clear. See you in my next video. Bye bye.